So intermediate value theorem. Let's start in on the technical stuff here, and we'll draw a picture even to make the technical stuff make sense. If a function is continuous between a and b, f of a does not equal f of b. So like there's, it changes. It doesn't start and end the same. And k is any number between f of a and f of b. I'll draw a picture. It can be a small picture, but a picture. And again, if you get stuck, you just think back to little Susie here. Started at 7 pounds. Oh, I don't know. We could draw something funny to represent her weight, but it's continuous. However you want to get from 7 to 137. I don't know. Now that we're talking about this poor girl's weight, I don't want to do something crazy. Probably not healthy if a kid does it that much, but as an adult, that might happen. So there's a to b, f of a, f of b. It's continuous. Then there is at least one number c. Oops, back up. K is any number between f of a and f of b. So there's k in between the two y values. That's the intermediate part. Actually, there's two intermediate parts. K is in the middle. Then there's at least one c that's also in the middle. The way I drew this, there might be more than one c. At least one that's in the middle. Right? She could have been 86 pounds a couple different times. But she was definitely 86 pounds once. At least once. So the intermediate part is here's the super slingy way to say it. If y is intermediate, then x is intermediate. The y is in the middle of the y's, then there has to be an x that's in the middle of the x's. At least one. So IVT guarantees that every y value between f of a and f of b must exist for some x value between a and b. It gets confusing using a's and b's and f of a and f of b and k and c. If y is in the middle, then there's got to be at least one x in the middle. Let's do an example. Given that h is a continuous function, h of t represents the height of a tree at time t. H is in meters, t is in years. And we don't have a formula, but we have a table. Explain why there must be some time at which the height of the tree is 17 meters. So you tell me, how do you know that the tree is 17 meters at some time? Go ahead. It's like,
I mean, it has to grow. And
okay.
It goes up to 27. So 17 has to be.
Okay. So that's a pretty good answer. You left out one thing. You said it has to grow. By that you meant continuous. And so we do have to say that h of t is continuous. You said grow, but I interpreted that to mean continuous. And that was given to us. It was continuous. That makes sense. And then you said it has to be in there because it reaches 27.
Oh, and it starts at 27.
Good. So you got to, when you're in your explanation, you got to include the start and the stop. So you can't just say, well, it reaches 27. You have to state where it started. Now, you said 0.7 to 27, and that is okay to use those because 17 is in between there. Most calculus teachers and most calculus books are going to use sort of the narrowest region possible. So it would be completely okay and accurate to say 0.7 to 27, but we're always going to use the narrowest possible region. Again, I'm not going to count it wrong if you go 0.7 to 27, because it's right. Or if you even did 3.2 to 21.2. As long as 17 is intermediate to your y values, then you're good. So let's say that h of 3 is 3.2. H of 6 is 19.3. I don't know. Sometimes this feels like tedious. Like, well, so of course it works. But like, what do I need to say to prove that it works or show that it works? Well, I need to say that 17 is between 3.2 and 19.3. And so that's literally what I'm going to write. 17 is between 3.2 and 19.3. That's how my brain sees it. 17 is like right in there somewhere. Probably closer to 6 than to 3, but don't know, doesn't matter. Now, if your brain is thinking a little more mathy, then you can write it as 3.2 is less than or equal to 17 is less than or equal to 19.3. That says the same thing. It says it's shorter, but maybe it's not as intuitive to write it like that. So if you're thinking through it, you might write it out. If you really have a grasp of what's going on, you might shortcut it and just say it like that. Those are identical statements, so say them either way you like. Okay. So if 17 is between those two y values, then there is a t, we're doing t rather than x, between 3 and 6, where h of t equals 17. Here's the 3 steps I need to see for an IVT proof. Step 1, continuity. So say it's continuous. Step 2, again, I'm trying to abbreviate this as much as possible. Y value is intermediate. Show and state that the y is in between the two y values. And then your conclusion is that the x value is intermediate. And this sort of follows, it is the pattern of an if-then statement. If it's continuous and the y is in between the y's, then the x is in between the x's. That's the IVT. If continuous and y values are in the middle, then there's an x value that's in the middle. And we don't know enough on this one to guess where the x value is. All we can say is it's between 3 and 6. So there's 2 formal things on this test. It's probably 2 more than normal on formal things on a test. The definition of continuity, left limit equals right limit equals, they're both 3-step things. I guess maybe that helps. Left limit equals right limit equals function value. And then intermediate value theorem, if continuous and y value, then x value are intermediate. Number 2, let's do one with an equation rather than a table. Explain why there must be a value of c in the interval 0 to 3 such that g of c equals -1. So must be, that's an exist kind of thing. There must exist on this interval. That means intermediate value. So those are sort of the clues. I mean, obviously today is IVT day, so it's an IVT problem. But like if this problem was on its own, how would we know that it's IVT? Well, when it's talking about existing between 0 and 3, that's our intermediate value theorem problem. Okay, so our 3 steps if continuous and y values, then we make some statement about the x value. So that alone doesn't get us many points, but sort of outlines the process for what we're going to follow. So for this one, I can just say g of x is continuous because it's a polynomial. All polynomials are continuous, so we like them on this stuff because you don't have to worry about proving or showing that something's continuous. All right, I don't have any y values. Like the table, it just gave me the y values. So how can I find my y values to see if -1 is in between the y values? Give me some x values. How do I find the y values? Plug them in. So I need g of 0 and g of 3. And then hopefully -1 is in between those two, but we'll see. If it's not, then somebody made a mistake writing this problem. So plug in 0, we get -2. Plug in 3, 27 minus 9 plus 3 minus 2. So 18 plus 3 is 21, minus 2 is 19. So yes, -1 is in between there, but you have to say it, right? You can't just be like, yeah, it's right there. Like, no, you have to say what you're thinking. And you can write it out like we did earlier. -1 is between -2 and 19. Or you can just shortcut it with some math symbols that says -1 is in between -2 and 19. Which means, so it's continuous, the y value is in the middle, therefore the x value is in the middle. So my conclusion is there is some, I could say x, but it wanted me to use c, between 0 and 3, where g of c equals -1. If you put x in there, it would be fine. There's some places where AP graders are like super sticklers and others where they're like, x, c, t, whatever. You got the problem right. We're not so worried about the variable. Part B. Find the value of c such that g of c equals -1. Okay, so there's the answer is -1, and we want to find where that happens. We're going to plug in -1 for the y value, and we should get an answer that's between 0 and 3. Like the IVT guarantees we get at least one answer between 0 and 3. Add 1 to both sides. Ugh, 4 terms. If this thing doesn't factor by grouping, then we're going to be stuck. Oh, that's nice of them. I think I did this problem wrong last period. Glad I recorded it this period rather than last period. So x equals 1. That's one answer. About x squared plus 1 equals 0. What does that lead to? Square root of -1. So that's imaginary. We're not worried about that one. I made a good mistake though last period, because the mistake led me to an answer that wasn't between 0 and 3. So I had to throw it out. So I got x equals 1, and I had another answer that wasn't between 0 and 3. So be careful. You're guaranteed to get at least one answer that works, but if you get other answers, you have to throw them out. You don't want to lose a point or two after having done all of the calculus right, and the only thing you didn't do was sort of recheck to make sure your answer was on the interval they asked for. All right, squeeze theorem. This is a fun one because it's an easy one, and it's hard to write a squeeze theorem problem that's anything other than super easy. So that's a good thing. If f is continuous and the graph of f lies between the graphs of g and h for all x in some interval. Okay, so let's draw a picture of what's going on here. So f is continuous. It lies between g and h. Oops, draw my picture where you can see it. There's why it's called the sandwich theorem, right? We make a sandwich of functions. F is always between g and h. So g and h are the top and bottom bread. F is the meat in the middle. Yummy. So we're setting up that's the sandwich part of the name. So if this is true, then if limit as x approaches c of g and limit as x approaches c of h equals L. Okay, so that picture doesn't really work anymore. I'm going to draw a new picture. At C, G goes to L, and H goes to L. And F is sandwiched, or in this case, squeezed in between there. Well, it sure seems like the limit for F should go to L. If you squish the sandwich down so that the top bread and the bottom bread were at the same point, well, then the meat's at the same point too. And the sandwich analogy kind of breaks down because now your sandwich and your bread have like 0 thickness to them. Welcome, Christian. You can sit at that desk or at the chair at my desk. And actually, on your way back, you can take this. Okay, so this is kind of a fun one. It's easy to understand. It's either the sandwich or the squeeze theorem. You can call it either one. And again, it's really hard to write a problem that's anything other than pretty easy for this. So let's look at an example. If f of x is not given, but it is known that f is continuous, and the graph of f lies between g and h. So it's like already we've got a squeeze or a sandwich setup here. Evaluate the limit as x approaches 1 for f of x. Okay, well, I don't know f of x, but I do know that it's sandwiched or squeezed between g and h. So let's check the limits for g and h. And if they go to the same thing, then we'll have our answer. So all I'm going to do is substitute and hope that the substitution works. So 1 minus 2 is -1. So g is going to -1. H, I plug in 1, I get -1. H is going to -1. So I've got g going to -1, I've got h going to -1, and f is sandwiched between there. What is f going to? -1. You know, 0 and 1, I don't know where you would even come up with those numbers. It is possible that you could get a cannot be found from this information. Do you know what would have happened to lead us to answer choice D? It's kind of a tough question to consider. If G and H didn't go to the same thing, then we wouldn't know anything. It's like, well, I know it's sandwiched between these two values, but I don't know what it is. So it only holds if it gets squeezed all the way down to one value. And then we know what the value is. Number 2 is the same thing. So I'm not going to plug it in. Basically, you plug in 2 to both of those, and if you get the same thing, that's your answer. If you don't get the same thing, then you don't have an answer. So squeeze theorem, sandwich theorem, fun to think about, fun to talk about, and easy to do. So we usually like the squeeze theorem problems. So today's assignment is worksheet number 5. Due tomorrow, this is second period, so due Thursday, are worksheets 1 through 5. We'll be back in the LGI, I hope. That way we can spread out. And because it's a block day, we'll be able to answer a few questions. I'm not going to do a full-on review. So come ready, but if you got 1 or 2 things that you weren't sure about, we will have time to address those on Thursday morning.